Hi guys, so in this video we'll be going over O-level physics 5054 chapter 1.5 forces. Previously we covered chapter 1.4 and 1.3. Now we'll be going over 1.5 and the later portion of 1.5 will be covered in part 2 of this video. So do come back for part 2 if you're interested. And we'll be going again point by point. So let us start at point 1. So balanced and unbalanced forces. These topics include, okay, so identify and use different types of forces, including weight, which is caused by gravitational force, friction, okay, so just frictional force, it's one type of resistance, drag. So drag basically means any kind of friction or whatever, like it's type of friction because it is opposing you and it pulls you backwards and whatnot. Drag happens because of, let's just say, liquids. Anything is a liquid actually. So air is also a liquid. So yeah, do remember that because air can take the shape of a container it is filled in. So checks out and then air can flow freely. So the particles don't really slide over each other like water flow and whatnot, but they can move past each other and whatnot, but they are not bound in place. So air is much more similar to a liquid than a solid. So drag happens because of any kind of liquid flow or viscous liquid or whatever. If I'm moving through any kind of thick liquid like oil and whatnot. So drag and air resistance is kind of the same. Tension. Tension is basically a force in a rope. So let's just say a rope is tied to the ceiling. There is a weight, and this weight is obviously pulling the rope downwards, right? So this rope will provide the exact opposite force to keep the weight in place. So this will be a tension force, which is going upwards. Tension P is going upwards, and weight W will be pushing down. Okay, so electrostatic force. Electrostatic force basically means the attraction of electrons. So if you rub your hands in your hair, legit hands in your hair actually. So take your hands, rub it through your hair, then your hand will become, let's just say, negatively charged. Imagine this is the surface of your hand. If you zoom in, this patch of your hand surface, so there will be electrons and whatnot with negative signs. So a bunch of negative electrons will gather. So if you take it to a positive source, like a pole, let's just say this has a positive charge on it, your hand will feel a very slight attraction. So your hand will be attracted this way, and this will also be attracted this way. This is what they mean by electrostatic force. Magnetic force is pretty self-explanatory because it's due to magnets, right? And anyone who has ever played with magnets does know what magnetic force is. So, what is thrust? Well, thrust basically that just as means like assume it means a driving force. What is a driving force? A force that is moving you forward or keeping you in motion. So when you hear thrust, you probably hear about, I don't know, some kind of rocket ship or something like that. So a rocket ship will have an engine below, and this will provide huge amount of flame. These flames will provide the thrust, so the rocket can move upwards. And driving force can also be counted as thrust. So driving force is usually synonymous with cars and whatnot. So if a big lorry or something like that is going forward, so the force that is keeping the lorry moving will be called the driving force of the lorry. So that is more or less it. And the last force we have is called contact force. Contact force basically means the opposite force of weight, not exactly opposite in the literal sense. So assume the surface of the earth, you're standing on the surface. So this will be you. You're standing, so the weight of your body will push you downwards, something newtons, and your contact force is provided by your legs, right? Your legs will push against the weight of gravity and keep you standing upwards so you do not sink into the earth. So this force that is provided by your legs and whatnot is called the contact force or normal contact force or whatnot. So do remember that contact force will be exactly the same as your weight. So your 60 newtons is your weight. Your contact force will be also 60 newtons, but opposite. It will be upwards. And they will cancel each other out, so there is no resultant force. What is resultant force? We'll get into that. So these are the type of forces we'll be dealing with. Gravitational force will be your weight, which will be in newtons, not kg, do you remember? Your kg, 6 kg, will be multiplied by 9.8, let's just say. This will be your weight in newtons. Friction, car friction. Drag is also a type of friction, let's just assume. And air resistance is also friction. Like three types of frictions, it's more or less the same. And tension, as we have known, tension is the weight provided by a rope and whatnot. And electrostatic force is because of charges, positive and negative electrons. Magnetic force is understandable. And driving force is the force that keeps things moving. And contact force is your weight, opposite force, and whatnot. The force provided by your legs to keep your body from sinking to the ground. Okay, so point one done. And identify forces acting on an object and draw three body diagrams representing the forces. Identify the force. So they will give you a question, and the questions will come like this: a force is towards the right, 10 newtons. A force is downwards, 10 newtons, and there is a weight of 10 newtons. Go and find out the, or sorry, not find out. They'll say draw a three body diagram. So what do they mean by that? And when they say this, you have to basically sketch the forces and whatnot and how they are acting on one object. Let's assume all these forces are acting on a box. This will be your box. A force of 10 Newton rightwards and 10 plus 10, which will be 10 Newton pushing downwards with external force and plus the 10 meters of its own weight. So 20 Newton. So this line is a bit longer because it is 20 Newton. So this will literally be your free body diagram. It's a diagram with all the forces pointing in the correct direction and whatnot. So I drew the line forces here. Like they could just keep the force in words. They will literally say, okay, so the force downwards is 10 newtons. So they will literally write this out in English and then you have to read it out and draw the diagram. So free body diagrams are not that difficult. You just have to sketch it out for 1 or 2 months. And let's move on to point three. Take Newton's first law as an object either remains at rest or continues to move in a straight line at constant speed unless acted on the resultant. Newton's first law is object either remains at rest or continues to move. So an object, a box, let's just assume, if it is stationary, if it is not moving, it will stay at. If it is moving, if it is moving, let's just say towards the right, it will keep moving towards the right until it is stopped by a resultant. It will keep moving in a straight line. If it is moving upwards, it will move up. If it is moving down, it will move down. And keep moving down unless it is acted on by a resultant force. So this is literally the definition, and you just understand it and memorize it. So when they ask for state the third law of Newton, you just write the whole thing out. An object remains at rest or continues to move in a straight line unless it is acted on by an external force or resultant force. Yeah, sorry, resultant force. So Newton's third law state that a force may change the velocity of an object by changing the direction of motion or its speed. So on point 4, state that a force may change the velocity of an object by changing its direction of motion or its speed. Okay, state that a force may change the velocity. So if a car or a box, let's just say box is easier, is traveling this way at, I don't know, let's just assume 5 ms, and then if a force is applied upwards to the box, right? So if a force of 5 Newton is applied, the box will change in the box is traveling to the right, then it will change its direction of travel. So after the force is applied, the box will travel this way. So in theory, the box will actually face this way and whatnot. Will face upwards and keep traveling this way. So changes direction of motion or its speed. How does it change the speed? So if the force is applied against the movement, right, then the speed will decrease. If a force of 5 Newton is applied against the movement, then the box will, let's just assume, slow down to 4 Newtons. So you have to only state that the velocity may change. So it's not that deep or not that much explanation. You just only have to know this and state this. So let's move on to the next one. Determine the result of two or more forces acting along the same straight line. So when two or more forces act, as I have shown before, if a force of 10 Newton is acting this way, and you again add like 10 Newtons to it, yeah, the forces will add and become 20 Newtons. If this was 15 and this was 5, this will still be 20 Newtons. If the force is in opposite direction, whether this is 15 and this is 5, and they are all acting on the same line or on the same box in opposite direction. When they mean acting along the same line, they just mean on the same plane. So this is the x plane, this will be the y plane, and vice versa. You can take any plane you want because there are infinite possibilities, but normally we work with x and y plane. So if they are in opposite, the forces are opposite moving to each other, then the force will cancel each other out and the algebraic sum will be your answer. So the algebraic sum will be, 15 minus 5 will be 10. So 10 Newtons towards the left will be the resultant force. So number 5, then recall and use the equation resultant force equals mass into acceleration. So this is a fundamental equation of motion. So resultant force in Newtons will be equals to mass, which should be kg, into the acceleration of the body. So in a meters per second square. So how does this work? Imagine a box with 1 kilogram of weight, 1 kg, 1 kg of, so the weight is 1 kg and a force of 5 Newton is applied upwards to the box. What will be the acceleration? The question asks you, find the ACC or acceleration. Acceleration equals to question. So how do you do this? So you just use F equals ma, F equals m, and the force is 5 Newton, the mass is 1. So acceleration will be 5 by 1. So acceleration It's 5 meters per second square. The speed is changing at 5 meters per second square. It's a simple formula, F equals ma. The maths on this formula is usually not that hard because there are only three variables. So we'll do examples when you get to question papers and whatnot. Point 6 and point 7 state Newton's third law as when object A exerts a force on object B, then object B also exerts a force on object A. And these forces are equal and opposite. Again, you just have to memorize this thing and throw it out in the question paper, right? If they ask you what is third law. How does it work? So imagine a wall and you are standing here and you just kick the wall, right? You just kick the wall. So you kick the wall with 5 Newton, the wall will push you back with 5 Newtons. So you both will cancel each other out. Always remember object A, object B, right? It has to be a different object. You cannot like expect to punch yourself or something like that. And I mean, it normally works this way because your body is elastic and whatnot, so it becomes two objects. It doesn't matter. Just remember that it has to be different objects, right? It cannot be the same object. So we understood that two objects equal and opposite force are provided on each other, and this alone is called Newton's third law. Equal and opposite reaction you might have heard in earlier classes in physics and whatnot. So this is on all on chapters or point 7, and point 8 would be know that Newton's third law describes pairs of forces of the same type acting on different objects. So the force has to be of same type, meaning if one force, let's just say you kick with gravitational force, so G, you cannot expect to get a magnetic force mg to counteract you. So the forces have to be same type and pair. So the forces have to be like kind of identical or equal to each other, right? If one is 5 newtons, like 5 newtons, the other one will also be 5 newtons backwards. So they have to be of the same type and a pair acting on the same plane. So that's more or less on all on chapter 1.5. The later chapter is quite big, so we'll cover that one in the next video. Before we end it, these are the notes from Z notes. If you want to take a look, then you can go ahead. But there is not much provided here because all the explanations I kind of gave already. And most of the notes here are for next classes and whatnot, so it will not really help that much. So I guess that is all for today. So goodbye.